The forest does not forgive small mistakes. In the humid heart of equatorial Africa, where chimpanzees live pressed shoulder to shoulder with heat, moisture, insects, and bacteria, survival is rarely decided by dramatic violence. It is decided quietly, slowly, and often invisibly by infection. A shallow cut can rot into a fatal wound. A parasite can sap strength long before predators arrive. In this world, brute strength matters far less than vigilance, restraint, and biological awareness. This is where the chimpanzee reveals one of its least celebrated but most critical survival roles. Not hunter, not toolmaker, not alpha strategist, but field medic. The camera lingers close, refusing spectacle. A chimpanzee sits in dappled light beneath a strangler fig, its posture slightly hunched, one arm held away from the body. The fur along the forearm is parted deliberately with long fingers. Beneath it, the skin shows a narrow gash, not fresh, but not healed, its edges darkened. The chimp lowers its face, nostrils flaring briefly, then extends its tongue and presses it against the wound. This is not frantic licking. It is slow, controlled, almost surgical. Saliva coats the skin, then the chimp pauses, scanning the surrounding forest before repeating the action. What looks unsanitary to human eyes is, in fact, a calculated biological response. Chimpanzee saliva contains antimicrobial compounds that inhibit bacterial growth, buying time in an ecosystem where time is often the only medicine available. In the wild, wounds rarely close cleanly. Constant movement through thorned undergrowth reopens scabs. Flies lay eggs in moist tissue. Bacteria thrive in heat. Chimpanzees respond not by ignoring injury, but by restructuring daily life around it. An injured individual slows its travel, choosing routes that avoid dense vines and abrasive bark. It climbs less aggressively, rests more frequently, and positions itself centrally within the group, rather than on exposed edges. These choices are not random behavioral side effects of pain. They are strategic adjustments that reduce re-injury, conserve energy for immune response, and lower exposure to parasites. Healing for a chimpanzee is not passive recovery. It is active risk management. Grooming becomes a medical act. Companions gather around the injured chimp, fingers combing fur with precision, stopping repeatedly near the wound. Parasites are removed not only from the injury site, but from surrounding areas, reducing secondary infection risks. Groomers spend longer on injured individuals than on healthy ones, and they focus their attention asymmetrically, returning again and again to the same vulnerable region. This sustained attention costs time and increases exposure to predators, yet it persists. From an evolutionary perspective, this makes sense. Chimpanzee societies are built on long-term alliances. Preserving a valuable group member preserves hunting efficiency, territorial defense, and social stability. Medicine here is social. The forest itself becomes a pharmacy. The chimpanzee rises and moves with intention toward a patch of low vegetation, bypassing dozens of edible plants without pause. It stops at a specific species, plucks several leaves, and begins to manipulate them with its hands. Instead of chewing immediately, the chimp folds the leaves carefully, presses them into a compact shape, and swallows them whole. These leaves pass through the digestive system largely intact. Their purpose is not nutrition. Their surfaces are rough, covered in microscopic hooks that physically scrape intestinal walls as they move through the gut, dislodging parasitic worms and carrying them out of the body. This behavior, documented repeatedly across wild populations, is one of the clearest examples of non-human animals practicing mechanical self-medication. At other times, the chimp chews bitter pith extracted from woody stems, grimacing as the taste floods its mouth. These compounds offer no caloric reward. Instead, they contain bioactive chemicals that inhibit parasites, reduce inflammation, and suppress microbial growth. The chimp consumes them in small, deliberate quantities, often during periods of visible lethargy or digestive distress. This is not desperation eating. It is targeted dosing. The behavior appears primarily in sick or injured individuals and disappears once symptoms subside. The forest, for a chimpanzee, is not just habitat. It is an indexed medical reference, memorized through observation, experience, and social learning. What makes this behavior remarkable is not simply that chimpanzees use plants medicinally, but that they handle them differently depending on context. Nutritional foods are chewed thoroughly. Medicinal plants are swallowed, sucked, or partially processed in specific ways that preserve their functional properties. This distinction reveals a cognitive layer often underestimated. The chimpanzee is not blindly following instinct. It is applying conditional rules. When the body is compromised, behavior changes. When parasites rise, bitter compounds appear in the diet. When wounds open, grooming intensifies and movement slows. This is adaptive physiology expressed through behavior. The camera follows an injured chimp through the canopy as dusk approaches. Light fades quickly beneath the leaves, and with it, danger rises. Instead of climbing high to nest, the chimp settles lower than usual, choosing a thicker branch with more stable support. Nest construction is slower, more deliberate. Each branch is tested before weight is committed. A fall would be catastrophic. This altered nesting behavior is not permanent. Healthy chimps often sleep higher, safer from ground predators. But injury changes the equation. Stability now outweighs elevation. The chimpanzee is making a risk calculation, balancing predator avoidance against the danger of collapse under its own weight. Infections do not announce themselves loudly. They drain energy, dull reflexes, and cloud judgment. For a species that relies on complex social coordination and rapid movement, even minor cognitive impairment can be fatal. Chimpanzees respond by minimizing additional stresses. Aggressive interactions decline. Injured individuals avoid dominance contests and remain close to trusted allies. This social buffering reduces cortisol levels, supporting immune function and accelerating recovery. Again, what looks like emotional comfort is physiological strategy. The boundary between psychology and biology dissolves here. Stress management becomes immune defense. One of the most misunderstood aspects of chimpanzee health behavior is what humans often label as disgusting. Wound licking, feces inspection, parasite handling. These actions violate human hygiene norms, but those norms evolved in environments with artificial sanitation and antibiotics. In the forest, cleanliness means something else entirely. It means microbial control, not microbial absence. Licking a wound introduces saliva that inhibits bacterial growth. Inspecting feces allows early detection of parasites. Removing ticks with bare fingers prevents blood loss and disease transmission. These behaviors are not careless. They are tuned precisely to the ecological realities chimpanzees face. Over generations, these medical behaviors have been refined by natural selection. Individuals that ignored minor injuries died quietly. Those that adjusted behavior survived long enough to reproduce. Over time, attentiveness became instinctual, and instinct became culture. Young chimpanzees watch elders groom wounds, select plants, and alter routines. They imitate not blindly but selectively, internalizing the context in which these behaviors appear. This transmission of medical knowledge does not require language. It requires observation, patience, and social tolerance. The forest is both classroom and testing ground. The camera pulls back to reveal the broader ecosystem. Humidity clings to leaves. Insects hum constantly. Fungi bloom on fallen logs. This is a microbial battlefield. Every organism here is under constant assault from unseen enemies. The chimpanzee survives not by eliminating these threats, but by managing them. Its immune system is strong, but not invincible. Behavior bridges the gap between physiology and environment, extending survival beyond what biology alone could achieve. By morning, the injured chimp moves more freely. The wound has not vanished, but its edges are cleaner, less inflamed. Grooming continues. Medicinal plants are no longer sought. Normal feeding resumes. Recovery here is not miraculous. It is incremental, earned through 1,000 small decisions made correctly. The forest did not heal the chimpanzee. The chimpanzee healed itself. using the forest as a toolkit. The realization settles slowly, uncomfortably. What humans often dismiss as animal instinct is in fact adaptive intelligence shaped by relentless ecological pressure. The chimpanzee does not understand microbes as humans do, but it understands their consequences. It does not conceptualize medicine, but it practices it. In a world without hospitals, without antiseptics, without antibiotics, survival depends on noticing the quiet signals of decay and responding before they escalate. This is not primitive behavior. It is precise, contextual, and effective. The camera fades on the chimpanzee as it disappears into the foliage, its movements cautious but confident. Somewhere beneath the fur, immune cells are working, supported by behavioral choices that reduced risk and conserved strength. This is what medicine looks like before civilization named it. Not sterile rooms or white coats, but attention, restraint, and an intimate understanding of one's own vulnerability. In the forest, the chimpanzee survives not because it is strong, but because it knows when it is weak and acts accordingly. In the lowland forests of Central and South America, survival is rarely threatened by claws or teeth alone. The real danger hums, crawls, and bites in swarms too small to see clearly until it is too late. Mosquitoes inject parasites that rot blood from the inside. Ticks burrow deep and carry bacteria that weaken joints and organs. Mites chew through skin, opening microscopic wounds that become entry points for fungal infection. In this environment, the smallest enemies impose the greatest long-term cost. For capuchin monkeys, intelligence is not only a tool for cracking nuts or stealing fruit. It is a weapon deployed against insects, parasites, and the slow biological sabotage they inflict. The camera finds a troop of capuchins moving through mid-level branches, their pale faces alert, tails curled for balance. One individual pauses beside a cluster of citrus-scented leaves, tears them loose, and begins rubbing them vigorously across its arms, chest, and shoulders. Another picks up a crushed millipede, snapping it in half before smearing its secretions into the fur along its back. To an untrained eye, this looks like play, or confusion, or pointless ritual. In reality, it is chemical warfare. The capuchin is coating itself in compounds that repel insects, kill mites, and suppress microbial growth. This is not grooming. It is pest control. Self-anointing among capuchin monkeys is one of the clearest examples of animals deliberately altering their chemical profile to manipulate their environment. Millipedes release benzoquinones, chemicals toxic to many arthropods and irritating to parasites. Certain plants produce volatile oils that deter mosquitoes and ticks. When capuchins rub these substances into their fur, they create a moving chemical barrier, one that makes their bodies less attractive, less accessible, and less survivable to biting insects. The effect is not permanent. Oils evaporate. Secretions degrade. Which is why the behavior is repeated regularly, especially during humid seasons when parasite pressure spikes. The forest responds immediately. Insects veer away. Ticks fail to attach. Mites abandon exposed skin. What looks like an odd sensory indulgence is, in fact, an adaptive response to a parasite-rich ecosystem that punishes neglect. Capuchins that anoint themselves less frequently carry heavier parasite loads. Heavier parasite loads reduce stamina, slow reaction time, and compromise immune systems. Over time, this makes individuals easier prey and weaker competitors. Chemical defense is not optional. It is maintenance. The behavior becomes more complex as the camera widens to reveal others converging on the same resource. A single crushed millipede attracts half the troop. Hands reach in from all directions. Bodies press together. Fur is smeared across shoulders, backs, faces, and tails in a frenzy of rubbing. This is no longer individual hygiene. This is group anointing, and it transforms medicine into social event. Group anointing serves a practical purpose. Parasites do not respect personal boundaries. They move easily between individuals in close contact societies. By spreading insect-repelling chemicals across multiple bodies at once, capuchins reduce parasite transmission throughout the group. It is a form of collective immunity, achieved not through antibodies, but through shared chemistry. In environments where one infected individual can seed an outbreak of mites or lice across an entire troop, this behavior dramatically reduces long-term health costs. But the jungle does not offer unlimited supplies. Millipedes are finite. Medicinal plants are scattered. When a high-value chemical resource appears, competition erupts. The camera captures scuffles breaking out mid-anointing. Individuals shove, bite, and scream, attempting to monopolize the substance. Dominant monkeys assert control. Subordinates dart in for brief contact before being chased away. The medicine works, but it also destabilizes social order. Protection has a price. This tension reveals an important evolutionary trade-off. Chemical defense improves health, but increases aggression. Aggression risks injury. Injury invites infection. Capuchins navigate this balance constantly. They must decide when the parasite threat outweighs the risk of social conflict. Observations show that group anointing increases during peak insect seasons and declines when parasite pressure eases. This is not impulsive chaos. It is conditional behavior modulated by environmental cost. The substances themselves are not chosen randomly. Capuchins show clear preferences for specific plants and arthropods with proven insecticidal properties. They ignore visually similar species that lack chemical potency. This selectivity suggests learned recognition rather than instinct alone. Juveniles observe adults closely during anointing sessions, experimenting clumsily at first before refining technique. They learn which materials burn skin if overused, which repel insects most effectively, and how long to apply them. This is cultural transmission of medical knowledge, passed through observation rather than instruction. The irony is unavoidable. Humans associate medicine with calm, control, and precision. Capuchin medicine looks like pandemonium. Bodies collide. Screeches echo. Fur flies. Yet beneath the chaos lies biological logic. In a dense tropical forest, where parasites breed faster than immune systems adapt, chemical deterrence buys time. Time to forage. Time to reproduce. Time to avoid becoming weakened enough to be targeted by predators. Predators do not need to catch the fastest capuchin. They only need to catch the sick one. Jaguars, harpy eagles, and large snakes select for vulnerability. A monkey distracted by constant biting, itching, and blood loss moves less decisively. It hesitates. It misjudges distances. Parasites, in this sense, are indirect predators, softening prey for larger killers. Chemical anointing interrupts this cascade. It keeps the monkey sharp, responsive, and difficult to isolate. There is also a subtler physiological layer at work. Many insect bites trigger inflammatory responses that divert immune resources. By reducing bite frequency, capuchins preserve immune energy for other threats like internal parasites and wound healing. This allows for a more balanced immune response, reducing the risk of chronic inflammation that can quietly erode health. Once again, behavior extends physiology. The camera lingers on a capuchin's fur, slick with crushed plant oils, sunlight glinting off each hair. Insects hover briefly, then veer away. The monkey resumes foraging, cracking open hard fruit with stone tools, energy unbroken. Without the chemical shield, this efficiency would degrade over weeks, not hours. Survival here is cumulative. It is won by preventing small losses before they compound into fatal ones. What makes this behavior especially revealing is how it collapses the false divide between intelligence and instinct. The capuchin does not understand chemistry in human terms, but it understands effect. Certain smells mean fewer bites. Certain substances mean less itching. Certain actions mean better survival. Evolution rewards not understanding, but outcomes. Over generations, individuals that rubbed the right substances lived longer, reproduced more, and passed on both genes and learned behaviors. Intelligence here is not abstract problem solving. It is pattern recognition grounded in bodily consequence. As the anointing session winds down, tension dissipates. Individuals separate, each carrying a thin chemical film into the canopy. Grooming resumes, now less frantic, reinforcing bonds strained by competition moments earlier. Medicine caused conflict, but it also reaffirmed interdependence. Even rivals benefited from the shared shield. The group, as a whole, emerges healthier. This is the jungle pharmacy in its rawest form. No storage, no dosages, no prescriptions, just immediate access to biochemical tools embedded in the environment and deployed through social behavior. The capuchin monkey survives not by eliminating threats, but by manipulating the rules under which those threats operate. The final realization settles quietly. What appears playful or absurd is often the surface expression of deep evolutionary pressure. Capuchins are not indulging in strange rituals. They are responding to an ecosystem that attacks from the smallest scales first. Chemical warfare against bugs is not an accessory to survival. It is a frontline defense, written not in textbooks, but in fur, scent, and learned behavior. In the rainforest, intelligence does not always look elegant. Sometimes it looks like chaos, and works anyway. Madagascar does not offer abundance. It offers timing. The island's forests swing violently between feast and famine, drenched and brittle, green and skeletal, often within the same year. Rainfall arrives late or not at all. Fruits appear briefly, then vanish. Leaves harden, thicken, and arm themselves with toxins. In this environment, survival is not about finding food. It is about choosing which poisons you can afford today, so you do not die tomorrow. Lemurs evolved inside this constraint. And nowhere is it more evident than in how they eat when they are sick, stressed, or under internal attack. The camera opens on a dry, deciduous forest at the end of the long season without rain. The canopy is thin, branches bare and pale, leaves reduced to leathery remnants. Heat radiates from the ground. Insects are fewer now, but parasites remain, entrenched inside bodies rather than swarming outside them. A ring-tailed lemur moves deliberately along a branch, pausing to sniff before every bite. There is no casual feeding here. Each mouthful is evaluated, not for taste, but for consequence. On Madagascar, the digestive system is a frontline organ. Mistakes echo for weeks. Unlike primates living in lush continental forests, lemurs cannot rely on dietary variety to dilute toxins or offset nutritional imbalances. The island's plants evolved in isolation, free from many mammalian herbivores, and as a result, they invested heavily in chemical defense. Alkaloids, tannins, cyanogenic compounds, bitter resins, these are not rare. They are standard. For a lemur, eating is not a matter of preference, but of tolerance. Survival depends on knowing which compounds can be processed, which can be neutralized, and which must be avoided until the body is ready. That readiness changes with season, age, reproductive state, and parasite load. Lemurs track these changes with precision. At certain times of year, individuals increase consumption of bitter leaves that offer little energy but high chemical potency. These leaves suppress intestinal parasites, reduce gut inflammation, and alter microbial communities inside the digestive tract. The calories lost are recovered later, when safer fruits return. The timing matters. Consume these compounds too early and you starve. Too late, and parasites weaken you beyond recovery. This is not opportunistic feeding. It is scheduled intervention. The camera follows a sifaka leaping between trunks, landing near a shrub avoided for most of the year. The animal strips several leaves, chews briefly, then swallows with visible effort. Its face tightens. The taste is unpleasant by any mammalian standard. Yet this plant appears reliably at the same point each dry season in the diets of multiple lemur species. Fecal analysis later reveals why. Parasite loads drop sharply after its consumption. The lemur is not feeding. It is dosing. Madagascar forces this behavior because illness here is unforgiving. There are no fallback foods when strength fades. A lethargic lemur cannot simply slow down and wait. Predators do not pause. Competition does not soften. Even dehydration becomes more dangerous when parasites compromise nutrient absorption. Lemurs that misjudge their internal condition often disappear quietly, not torn apart, but thinned and hollowed from the inside until they fail to keep up. The forest records these failures without comment. This pressure shapes cognition. Lemurs do not need human-like foresight. They need pattern memory tied to bodily feedback. Certain plants correlate with relief. Certain fruits worsen discomfort. Certain smells precede recovery. Over generations, this association hardens into behavioral calendars. Young lemurs follow adults not just to food, but to timing. They observe when feeding shifts, when bitterness replaces sweetness, when chewing slows and selection becomes stricter. This is cultural pharmacology, built without language, preserved through survival. The irony is sharp. Madagascar is often portrayed as a place of playful, wide-eyed lemurs leaping through trees. In reality, their existence is defined by constraint. The island does not reward experimentation. It rewards restraint. Lemurs that eat indiscriminately die early. Lemurs that synchronize feeding with physiology endure. The digestive system becomes a site of constant negotiation. Lemur guts host microbial communities adapted to break down fibrous, toxin-rich diets. These microbes are not passive passengers. They are active participants, detoxifying compounds that would otherwise be lethal. But even these allies have limits. When parasite pressure rises, when water stress thickens blood and slows digestion, lemurs adjust intake to protect the microbiome itself. Medicine here is not external. It is the management of internal ecosystems. The camera lingers on a bamboo lemur stripping shoots with surgical precision. Bamboo contains cyanogenic compounds that release cyanide when digested. For most mammals, this would be fatal. Bamboo lemurs process it daily, but only within narrow margins. When stress increases or illness strikes, intake drops. The animal switches to lower-risk foods despite reduced energy gain. This shift is not intuitive. Hunger urges one choice. Physiology demands another. Survival depends on choosing the latter. Parasites exploit moments of weakness. During the dry season, when food scarcity slows gut movement, worms gain advantage. Lemurs respond by consuming specific plant parts high in secondary compounds that disrupt parasite metabolism. These compounds do not kill outright. They weaken, dislodge, and reduce reproductive output. It is not extermination. It is control. Complete elimination would damage the host as well. Lemurs, like all long-lived animals, evolved toward balance rather than purity. Predators lurk at the edges of this system. Fossors and raptors do not need to understand chemistry. They detect lag. A lemur slowed by internal distress leaps shorter, hesitates longer, misjudges distance. Chemical mismanagement becomes physical vulnerability. The stomach here decides who is hunted. As rains return, the forest changes character. New leaves flush bright green, fruits swell, sugars flood back into the system. Lemurs shift again. Bitter plants recede from the diet. Energy intake spikes. Reproduction follows. But the memory of scarcity remains embedded in behavior. Even during abundance, certain medicinal foods are sampled lightly, maintaining low parasite levels ahead of the next dry collapse. The calendar never disappears. It stretches. The wow moment arrives not through spectacle, but realization. On Madagascar, digestion is not private. It is ecological. What a lemur eats affects which parasites survive, which microbes flourish, which predators succeed. The stomach becomes a battleground where plant defenses, microbial allies, parasitic invaders, and host physiology collide daily. Every meal is an intervention. Every choice leaves a trace. This is why lemurs appear selective to the point of obsession. They sniff, taste, reject, return, sample again. To an outsider, it looks inefficient. To the ecosystem, it is precision. The island stripped away redundancy. What remains is a primate lineage that treats food as both nourishment and threat, medicine and weapon, timed with a discipline few mammals ever need. As the chapter closes, a lemur settles on a high branch, chewing slowly. Eyes half closed, the forest quiet beneath it. Inside its body, parasites struggle, microbes adjust, toxins are neutralized or endured. Nothing dramatic happens, and that is the point. On Madagascar, survival belongs to those who prevent crises before they announce themselves. The lemur does not conquer the island. It negotiates with it, meal by meal, season by season, proving that on this island, your stomach is not just an organ. It is part of the ecosystem's war. In the high canopy of Borneo and Sumatra, silence is not absence. It is strategy. The forest here is dense, layered and slow-moving, a place where motion costs energy and mistakes compound quietly. Orangutans evolved inside this stillness, not as social negotiators or collective problem solvers, but as solitary specialists. They live far apart, meet infrequently, and spend long stretches alone. This isolation reshaped every aspect of their biology, including how they deal with injury, infection, and physical breakdown. For an orangutan, there is no backup, no grooming circle, no alliance that will tend a wound while you rest. Healing is private, deliberate, and unforgivingly personal. The camera finds an adult orangutan moving through the canopy with measured restraint. Each hand tests a branch before committing weight. Muscles shift under thick fur, powerful but economical, conserving energy in a forest where calories arrive sporadically. This is not the urgency of a group keeping pace. This is solitary pacing, optimized for endurance. The orangutan pauses, lifts one arm and turns its wrist inward. Fingers part the hair with care, exposing a patch of skin rubbed raw. The animal does not flinch. It examines. This pause is not incidental. It is assessment. Orangutans cannot afford to ignore minor injuries. A small abrasion can become infected. An infection can sap strength. Weakness can strand an individual in a canopy that demands constant grip strength and balance. Falling is not dramatic here. It is fatal. The orangutan responds with a precision that reflects this reality. It lowers its head, sniffs the exposed skin, then reaches deliberately toward a cluster of leaves nearby. Not just any leaves. These are selected with specificity born of long experience. The orangutan plucks several, chews them slowly, then stops before swallowing. Instead, it presses the softened plant matter directly against the irritated skin, rubbing it in with broad, slow strokes. This is not feeding behavior. This is topical application. The leaves contain anti-inflammatory and antimicrobial compounds. Their juices reduce swelling, suppress bacterial growth, and create a chemical barrier against insects. The orangutan holds the paste in place, then repeats the process. No urgency, no wasted motion. In a solitary life, thoroughness replaces speed. This behavior matters because orangutans cannot rely on others to clean wounds, remove parasites, or monitor healing. Chimpanzees survive infection partly through social grooming. Capuchins rely on group anointing. Orangutans have none of that infrastructure. Their social system is dispersed. Encounters are rare and brief. Mothers raise offspring alone for years. Adult males roam vast territories without consistent contact. In this context, self-care becomes a survival trait, not a luxury. The forest again becomes a pharmacy, but one accessed alone. Orangutans show remarkable knowledge of medicinal plants, not just ingesting them, but applying them externally. Observations reveal individuals chewing specific leaves and rubbing them onto joints, skin irritations, and insect bites. These are not random acts. The same plant species appear repeatedly in the same contexts across different individuals. This consistency points to learned behavior preserved through long lifespans rather than social teaching. Knowledge accumulates inside one body, one mind. The camera tightens on the orangutan's hands. These are not clumsy tools. They are slow, sensitive instruments. Fingertips explore texture, temperature, and resistance. Orangutans possess dense sensory innervation in their hands, allowing fine discrimination. This tactile awareness is critical when applying plant matter to damaged skin. Too much pressure reopens wounds. Too little fails to spread compounds effectively. The orangutan modulates force instinctively, guided by feedback rather than instruction. Isolation also changes how orangutans manage pain. Pain is information, but responding dramatically wastes energy and attracts attention. Orangutans display minimal outward reaction to injury. not because they feel less, but because expression offers no advantage. Instead, they respond by adjusting movement patterns. Climbing routes shift. Risky gaps are avoided. Rest periods lengthen. These changes reduce mechanical stress on injured areas, allowing healing without drawing notice. Pain becomes a guide, not a signal. Parasites pose a quieter threat. In humid forests, insects target exposed skin relentlessly. Without grooming partners, orangutans rely on behavioral spacing and chemical deterrence. They choose nesting sites with airflow that discourages mosquitoes. They build sleeping platforms high and isolated, reducing contact with crawling parasites. When bites occur, they again turn to plant-based solutions, rubbing crushed leaves into fur and skin. The result is not complete protection, but reduction. In a solitary system, reduction is enough. The camera follows an orangutan constructing its night nest. Branches are bent, not broken, woven into a stable platform. The process is slow, deliberate, almost architectural. Nesting is not just rest, it is recovery. Orangutans build new nests each night, selecting sites that minimize exposure to rain, insects, and wind. For an injured individual, nest placement becomes critical. Stability matters more than view. Comfort matters more than territory. The nest becomes a clinic bed suspended above the forest floor. The biological context deepens this behavior. Orangutans have slow metabolisms compared to other primates. This conserves energy, but slows healing. Infections linger longer. Inflammation resolves gradually. To compensate, orangutans minimize additional stresses aggressively. They avoid unnecessary movement. They feed selectively, favoring foods that support immune function, even when they provide fewer calories. This trade-off would be disastrous for a social primate that needs to compete constantly. For a solitary one, it is viable. The camera shifts to a mother and infant. The infant clings tightly, its fingers buried in fur. The mother pauses to groom herself, then gently rubs plant matter onto the infant's skin as well. This is not teaching in a human sense. It is demonstration embedded in care. The infant absorbs not instruction, but pattern. Over years, these repeated acts build an internal library of responses. When the young orangutan eventually lives alone, it will not need guidance. Its body will already know. Predators remain an ever-present pressure. Clouded leopards and large pythons do not target strength. They target vulnerability. An orangutan that hesitates, that climbs poorly, that bleeds or smells of infection, becomes visible. Chemical self-treatment reduces odor cues that attract insects, which in turn reduces secondary signals predators exploit. Healing is not just about recovery, it is about invisibility. The wow moment emerges quietly, without spectacle. This is medicine stripped of all social support. No shared knowledge pool, no cooperative care. Just one organism negotiating directly with an environment that does not pause. The orangutan does not understand microbes or inflammation. It does not conceptualize surgery, but it performs its equivalent with consistency and effectiveness. Leaves become antiseptics. Hands become instruments. The canopy becomes both operating room and recovery ward. What is most striking is the restraint. Orangutans do not overuse these plant treatments. They apply them when needed, then stop. Over-application can irritate skin or waste resources. This implies feedback-based regulation. Relief reinforces behavior. Discomfort suppresses it. Over time, this fine-tuning produces efficiency. Intelligence here is not abstract reasoning. It is embodied calibration. As dawn breaks, the orangutan stirs, tests the treated area again, then resumes movement. The injury has not vanished, but it no longer dictates behavior. The animal moves forward, not healed, but stabilized. In this forest, stabilization is success. The chapter closes with the orangutan disappearing into layers of green, alone but not unprepared. Its survival does not depend on strength in numbers or social safety nets. It depends on attention, memory, and the ability to turn the environment into a set of tools when no one else is coming to help. This is the solo surgeon strategy, refined by isolation and enforced by consequence. In the canopy, medicine is not shared. It is earned, applied, and carried alone.